I'd like to go through a scatter plot with you and the directions for on the calculator. First of all, a scatter plot is a graph with a set of data points. And every time you have a scatter plot, you can use the mathematical regression method to find the best fit curve. Regression is a method mathematically that will find any curve. And since we are in the linear chapter, we are going to talk about linear regression. So it will find the best fit line using the least squares method. Whenever you have a line, you will also have a correlation coefficient. A correlation coefficient is known as R, and it tells how close the line fits the data. If my data is basically spread to the right, it would say to have a positive correlation. For instance, I could probably fit a line like that. This line would be close to 1. I'd say this would have an R of approximately 0.8025. That is 80% of the points will fall on that line. R is close to 1. If my line basically leads to the left, we would say my R should be close to a -1. This one I would say is even stronger relationship, so this would probably be like R equals 0.9. We'll always list our R to 4 decimal places. When you can't draw a positive or a negative sloped line through it, we say there is relatively no correlation. Your R is going to be close to 0. If 100% of the points fall on the line, we say it is an exact positive fit when R is a +1. If all of the points fall exactly on the line as it slopes negative, we say it is an exact negative correlation with an R of -1. All right, so let's put this data in our table. And when we are entering data, we never want to enter like the exact year it says. We always want to enter a rounded year. For instance, this says the years of 1991, 92, 93, 94, and 95. So if we enter that as 1991, our calculator reads that as 1,991. It would probably be more useful to actually have the year since 1990. So we would enter this as 1, 2, 3, 4, 5. And our first list should be our X's. And our second list should be our Y's. And that is how many computers were sold per 1,000 people. So if we're going to enter this data, we want to press our stats key. And then to enter any data, you always press edit. And to clear a list, should you have information, you go up onto the list and hit clear, enter. I need to clear out list 2, clear, enter. You do not want to delete them. You want to clear them. So in list 1, we're going to enter 1, enter, 2, enter, 3, enter, 4, enter, 5, enter. In list 2, we're going to enter 245.4, 266.9, 329.2, and 364.7. We should always check our data. Looks like I might have forgot one. I have 245.4, 266.9. Oh, right here I need to insert. So insert is above our delete key, so I need second delete. And I want to insert 296.6, 329.2, 264.7. Okay, now I've double checked my data and it's all correct. So I still don't see this scatter plot. So do you see plot above your y equals? So you'll press second. Anything in blue needs a second key. Second, y equals. And I want to turn my plot on, so I hit enter. And move on to the blinking on and hit enter. Then we still don't see our plot, so we're going to choose zoom. And we want to zoom stat, because that's where we entered the information. So zoom stat, enter. And we see our plot. So I'm going to plot that in here. And my X's were the year since 1990. And my Y's were the computers per 1,000 people. Okay, and if we want to see our window, I had the increments here, but if you want to see your window increments, you just press your window key. And your X-min was 0.7, so we could put that. Our max was 5.3, so we could put that. Our min was 237, we could have put that down here. And our max was 372, we could have put that up on top. Now it says write your linear model. Write your best fit line, write your model, write your equation, all means to do the regression. So we're going to press stat. And this is a calculate. And we want linear regression. Linear regression. The AX plus B, forming MX plus B. Enter. Our X's are in list 1, our Y's are in list 2, so we want to go down to calculate that. And if we wanted, right here, it says store reg EQ. You could tell it where to store the equation. So if I press my bars key here, and it's a function, a statistics function, or excuse me, a statistics, enter. And it is EQ, and it will be our reg EQ. And we want to store that in Y1. So vars functions Y1. And then choose calculate, enter. Y equals AX plus B. So it is Y equals A is 30.09X plus B is 210.29. And then it says interpret the slope. Well, that slope means that 30.09 computers per 1,000 people per year. So let's make it a sentence. There was an increase of 30.09 computers per 1,000 people per year. That tells us what that slope stands for according to the problem. Use your function to estimate the number of computers in 1994. Well, that would be looking for f of 4. So since we stored this in our y equals, we just press our y equals and we can see the equation is right there. You can go right to your table, which is above graph, so go second table, and we're looking for f of 4. So if I go down, f of 4 is 330.65 computers per 1,000 people. Our actual was 329, so it's very close. In fact, if you want to know the difference, you can just quit and calculate how close. We should always say how close something is, not just that it's close. So second mode quits, and I want 330.65 minus my actual was 329.2. So I am 1.545 computers per 1,000 people greater than the actual. What is your correlation coefficient? Well, again, we need our equation. So I'm going to do my stat, calculate, linear regression, and when you're using the graphing calculator here on your iPad, you don't need to turn your R on. My R is 0.9961. So interpret the meaning. That is strong positive correlation. If you are using a Texas Instrument, you will need to turn on your correlation. So you would press second mode and go down to Stat Diagnostics and turn it on. If you're wondering, I have another video attached just for the TI calculator instructions. Now, I'd like to go up here and fill in this question. It says, in 1991, there were 57 million cats as pets in the U.S., and by 1998, there were 61 million. Write a linear model that represents this. How many cats were there to predict? Okay, so two things. Write the linear model, and then how many cats in 2010. Well, if I'm going to write the model, I'm going to create points here. So in 1991, there were 57 million cats. So in other words, would our slope be years per cat or cats per year? So our slope would be cats per year. So slope means y's over x's. So cats are our y's and years are our x's. And actually, I'm going to do the years since 1990. So 1991, 57 million cat. I'll do cats in millions. Will give us the data point 157. In 1998, there were 61 million cats, so that would give us the data point 861. So to find the slope, I'm going to start with this point. It would be 61 minus 57 over 8 minus 1. That gives me 4/7. So I can write my equation as y minus my y coordinate, and I'm going to use the point I began with. So y minus 57 equals slope times x minus my x coordinate. So this is y equals 4/7 x minus 4/7 plus 57 is plus 56 and 3/7. So there is my model. How many cats were in 2010? Well, 2010 to 1990 is 20 years. So f of 20. So when I put 20 in there, I get 4/7 times 20 plus 56 and 3/7. And that gives me about 68 million cats in 2010.